Finally, transportation, aviation, digital, all the other things we've talked about. And now we get to talk about water, which is the most important. Sorry, I'm just a little biased. So anyway, we have a great panel for you today on stormwater infrastructure. We're going to focus on the panelists' experience in managing stormwater infrastructure, both for their organizations and their communities. We're going to share tangible examples of how they've managed stormwater infrastructure and how they've dealt with the issues and opportunities that come with that. And we really hope to provide you with some actual real-world insight into how they've done this work that you can hopefully apply. So I guess I should introduce myself. My name's Karen Apple, as Ken said. I'm a vice president and climate adaptation lead for AECOM Metro New York. My past 6.5 years have been spent managing the Rebuild by Design Hudson River project. So I'm handing that off to our valiant construction team. We're in construction, and I'm still serving as the engineer of record. And I'm moving on to one of the cloudburst projects, managing one of the cloudburst projects for New York City DEP. So that's really exciting. We're getting going with that work. So I'm going to give our panelists each a chance to introduce themselves. Jared, you want to start?
Hi, good afternoon. My name is Jared Tomlin. I am the Stormwater Program Manager for the Stormwater Utility in the city of Martinsburg, West Virginia. So we are sort of the upstream reaches of the Chesapeake Bay. I've been there for 5 years. Before that, my professional background included scientific remote sensing and GIS. I spent a couple of terms at NASA Develop. And I've got my master's degree in environmental biology and my undergraduate in sustainability from Shepherd University. So I sort of fell into stormwater in the sort of transition of technology and regulation.
Good afternoon. I'm Ellie Mortazavi, Stormwater Program Coordinator with Department of Public Works, Newcastle County, State of Delaware. My primary focus is on BMP post-construction inspection and maintenance, which is one of the NPDES measures that we are in charge of implementation. We are NPDES Phase 1 permit holder, and we share the responsibility with the Department of Transportation in the state of Delaware because they own and maintain most of the roadways and its drainage infrastructures in the state of Delaware. As far as the background of the location, Newcastle County is the northernmost and the most populous 3 counties in the state of Delaware. The population is about 580,000, and the area is about 500 square miles, which is 13% of it is water, the rest of it is land.
Afternoon, folks. My name is Louis Linker. I'm with the EPA Chesapeake Bay Program Office. The Chesapeake Bay Program is the state and federal partnership for the states of New York down to Virginia, West Virginia, over to Delaware, and everything in between. The modeling team that I have the pleasure to lead has been developing the plans for restoring the Chesapeake and developing the plans for the nation's largest total maximum daily load. Lately, the governors of the Bay Program partner states and the EPA administrator have directed an assessment of what's needed to protect the Chesapeake, its living resources, and its watershed from future climate change. And that's what our modeling team is working on currently. I've received an undergraduate degree and a graduate degree from Towson and Johns Hopkins Whiting School of Engineering, respectively.
Okay, so some audience participation, because that's always fun at 4 o'clock in the afternoon. We want to get to know our audience. So just a show of hands, who in the room is a stormwater practitioner? So design or implementing stormwater. Okay, good. Who deals with phase one MPDES, so construction disturbance of greater than 5 acres? What about phase two, 1 to 5? Okay, so there you go, Ellie. You know who your audience is. Anyone in municipal and county government? Okay, a few. Anyone that takes calls directly from the public or has to deal with comments directly from the public? Okay, a few. And I hope everyone raises their hand on this one, not to give the answer, but who has stormwater flooding concerns, either at home or at work? Oh, come on, everybody should be raising their hand right now. Okay. The reason I ask that is because oftentimes when we do these types of panels where there's a lot of mix of different disciplines throughout the day, we don't always have, stormwater or even just water resources folks in the room. But some of the technical things we can talk about or not. But at the end of the day, everyone in this room is likely dealt with flooding issues either personally or with their job, or has to implement some sort of climate change or resilience type of policies to deal with flooding and stormwater, and I deal with a lot of coastal flooding as well. So it's an important topic to continue to talk about. So to get into our panelists' experience and their opinions on this topic, the first question is going to go to Jared. What is one thing that you think contributes to effective stormwater management?
So for this, initially I was going to respond with communication because I feel like communication is highly important, but I'm going to replace that a little bit with effective communication. I feel like that when it comes to anybody who works in stormwater or works with the minimum control measures, MCM 1 and 2 are all about communication and working together. But what I've found is that we spend a lot of time checking boxes so that our permits are good and we can get on to the work of fixing infrastructure and moderating floods. But at the same time, I've found that by falling short of the goal of being effective in your communication, then the legal system that you rely on to support your efforts, or the system of even pre-construction meetings and making sure that the people who are developing not just check the box and sign the document, but truly understand the impacts of the things that you're going over. I try to stress as much as possible to my team that our goal isn't to just check boxes. Our goal is to be informative and actually be effective, whether it's within city leadership, like I said, the legal system, or our own regulators at the state or federal level. So, 100% lean into that.
What about you, Ellie?
That's an interesting question. But for someone like me who spent more than 20 years working for a public agency, dealing with the maintenance and inspection of the BMPs, I would say inspection and maintenance, because the state-of-art facilities are out there. Designers, they design perfect systems. The regulations have changed. Permits are issued. Contractors, developers, builders, they make all the efforts. They spend tons of money to develop and build these facilities. But if they don't get inspected regularly or maintained properly, everything goes down to the hill. And everything is going to be wasted time, wasted effort, wasted money. I oversee more than 2,800 BMPs over 1 year in calendar year to inspect and make sure that the maintenance is being done. And what I have seen, I've seen all kinds of the BMPs, from the older design detention ponds all the way to permeable pavements, green roofs, bioretentions. They need maintenance no matter what. They need to be inspected. And unfortunately, in most cases, by the time that they are built, everybody forgets them, especially the underground systems, out of sight, out of mind. So that would be my answer.
So what I think is interesting about those two answers is you actually need effective communication in order to manage BMPs. Yeah, if you don't have an understanding of what needs to be done and what's old, what's new, what needs to be done here or there, and also effective communication with the community. And if you
Absolutely.
see something, say something from a maintenance perspective too.
Absolutely.
Okay, so let's flip it and say, what's the biggest obstacle that you have encountered or you think exists for effective stormwater management? So Lou will give you a chance to speak and put the microphone close to your face.
Thank you, Karen, and very good question. I'm going to second everything that Jared and Ellie have said, but also the most important obstacle that we have to face is getting it right in terms of future hydrologies. When we have a incorrect paradigm or a engineering principle of stationarity, which is dead because stationarity would say something like, the rainfall we're going to have tomorrow is much like the rainfall we had yesterday. Well, that's gone. Climate change has changed all of that. So how do we size for those stormwater management practices that Ellie is talking about putting in the ground and maintaining, and Jared has to oversee? How do we design for the ones that are coming in the future? Well, we need intensity, duration, frequency curves that are climate adjusted. The Chesapeake Bay program has been able to put together for its 304 counties climate adjusted IDF curves so that we can design stormwater management correctly for future stormwater. Now, that's the first step, but that's the first step in many steps that need to be taken to essentially get to the point where we have in the Northeast Corridor the correct infrastructure for stormwater. To give an example of the level of the problem, Negley Run watershed in Pennsylvania, for a 2.3-inch, 2-year storm, we have, under the current design manual, Atlas 14, 8 occurrences of that return period of a 2-year storm. But actually, we had 18. Or for the 100-year storm, we have, from the current plans of Atlas 14, 0.2 times for the 4.9 inches of the 100-year storm. But actually, what we've actually seen is 2. So we've got to get busy. We got to get cracking on this.
So Lou, just to follow up, and I'm going to put you on the spot. I know this is something that the agencies in New York City have been focused on is understanding, or just even thinking about the fact that the IDF curves are so off. So maybe our audience doesn't, with the limited number of stormwater practitioners that raise their hands, can you just explain, how you get the IDF curve, what's the data that goes into it, and what you use it for when you model? Maybe like just a 2-minute tutorial on that.
Sure,
because I think it's important that people understand from a stormwater perspective.
Right. For our region, Atlas 14 is our design manual for hydrology. It looks at the record of 50 years, a half century, and the half century we looked at was about 1950 to the year 2000. So for that hydrology that's passed, the intensity, the duration, and the frequency gives us storms that we can design our stormwater management practices to. Now, this Atlas 14 is going to be replaced with an Atlas 15. And by the end of this decade, it's going to be out for all of the US. And it's going to give us stormwater design that is climate corrected, like we already have in the Chesapeake watershed. But it's coming. And to have that design practice of getting an idea of what we have to get ready for future hydrologic events is the beginning point. What we need further would be essentially the guidance and the understanding of how to change ordinances and statutes and guidance at the local, state, and federal level.
Thanks, that was really helpful. So Ellie, what about you? What's the biggest obstacle to effective stormwater management?
I think at least in my field, it is the lack of proper knowledge of how to maintain these BMPs, and also the cost. very expensive, some of them, to maintain. And by the time that they are in the ground and they're ready to go, 6 months later, when we go back to the site and inspect it and send the report to the owner or to the community, they are like, oh, we had no clue that we had this. What are we gonna do? This is so expensive. And there is no, I'm not saying that there is no contractor out there that they know exactly what to do, but definitely there are not that many contractors who are professional to maintain an underground system or a bioretention. We have so many landscapers that they just go and cut the grass. They don't know that the bioswale needs to maintain at least the height of the grass should be minimum 10 to 12 inches. So lack of proper knowledge among the contractors, among the property owners, property management companies, as well as the homeowner association. Because in the state of Delaware, all the homeowner association, they do have maintenance responsibility for maintaining their open space as well as the stormwater management facilities. And we have so many New Yorkers, people from New Jersey, Connecticut, they are retired and they are moving to the state of Delaware because I guess it's a good state to be retired and to live. And they are calling us and they are saying that, oh, when we were in New York, we didn't have this responsibility. When we were in Connecticut, we didn't have responsibility. That doesn't make sense. Again, we are trying to teach, train, and have these community meetings and also with the property management companies and contractors to let them know, and we are asking designers and engineering firms when you are designing these BMPs, please come up with the maintenance table. We call it operation and maintenance plan. Put it on the construction plan because everybody, whoever has these facilities, they have to know what to do in the future years coming.
So many of you have probably in the outer boroughs more than Manhattan at this point have seen the right-of-way bioswales. So this is a really great example of, Ellie keeps referring to a BMP, a best management practice, which is what a lot of the green infrastructure elements or measures or installations are called, BMPs. I remember when they first started building the bioswales, and a lot of people just thought they were planting planters, right? They just looked like they were beautification type of, let's get some more greenery along the sidewalks, and people were parking on them and running over them or throwing trash into them or, all different things. And that the impact of the weight on the soil was actually ruining the whole purpose of these bioswales slowly infiltrating, letting water infiltrate into the drainage infrastructure underneath. So a lot of different things were done from the very beginning of installing these bioswales for construction, how to construct, but also O&M and just even how fences were designed around them and how curbs of permeable concrete were put in so people could actually step onto the concrete and not the soil. So very specific, changes and revisions to the designs, but also of how they're operated and maintained is very important. Is there a specific BMP, Ellie, that you can think of that it just became so onerous to operate and maintain, you just completely took it away from the typical repertoire of designs that you implement?
I would say the isolated rows, stormwater tech system, underground system, because when our inspectors, they go out, they visually cannot see anything. So what we decided to do a few years ago, we came up with this, we call it subsurface maintenance log. Every time that we send the inspection report, which is normally it's once a year, we actually send a copy of this log to the owner or the property management company and ask them to have their contractors to CCTV the system, make sure that it's maintained, make sure that the sediment has been removed, trash bins been removed, attach pictures, and the contractor has to sign and send us a log by end of the year. If they don't do proper maintenance or they don't show that they are performing maintenance, we are going to issue them a notice of violation.
So there you go. Perfect example of where you can forget about something because it's, subsurface and you don't remember that there's actually a water treatment or a stormwater treatment facility, underground that maybe someone prior to the building manager installed, and the building manager doesn't necessarily know what he needs to do or she needs to do to maintain it.
Exactly. The building, the owner is, they sold the property. The previous four owners and property maintenance gone. They never sent them anything, and they don't see anything that they have, at least for the ponds and the other, like a bioswales, they see it, but they don't have any idea under their parking lot. There's a huge system that needs to be maintained. So I told one of the owners that I don't want to see anything on the newspaper the day after that the parking lot is collapsed, because it's going to, pretty much people are going to sue the property owner. And he was like, oh, I had no idea that I had this facility under the parking lot. What I'm going to do? So again, lack of knowledge, communication, as Jared said, effective communication. It's a key. That's why we are trying to train people that, or whoever has these facilities, that they have to perform proper maintenance.
Okay, so back to you, Jared. Next question. What is one thing that you think our audience or you've seen that has been key to improving stormwater management?
So it's pretty rare, I would say, that I get a phone call from somebody in my office where the person on the other side of the line is extremely happy with what's going on, whether it's a legal thing, whether it's a maintenance thing. And, we just started our stormwater fee last year, earlier this year is when the fee first went into place. And the people who we have on our team are professionals, educated, capable people who are on the engineering side or on the construction side. But what they're not is crisis communicators. And what I didn't realize up until this day dropped, I mean, we would get calls about trees, we would get calls about flooding, obviously. But really, when you start sending out violations for stormwater control measures, or you start getting phone calls about a fee and people don't understand the impacts of impervious surface, which is what our fee is based on. The person that's on the other line isn't, we're not having a conversation like we're having now. And that is probably one of the biggest obstacles to get over. And I think in part that's because the people who we're hiring, we're not training to understand that what they're dealing with is essentially, to the person on their side, it's a crisis. And it could be a flooding scenario. Like I said, it could be trees, because that's very much, in our wheelhouse as well. When, things fall, leaf litter gets, on the catch basins and causes flooding and things like that. So, and I think that's something that I really wish that I had been introduced to before, getting further into this industry. So I believe that's something that could be implemented, and we could sort of nip some of those issues in the bud and try to help people.
So Jared, actually, let's back up for 1 minute. So the stormwater fee that you mentioned. So New York City, a few years ago, changed our stormwater laws and started introducing this type of requirement for property owners, to raise funds to help, manage stormwater. So in your case, you just started it last year, I think you said?
Earlier this year, in January this year is where the first fee went out.
So can you just explain to the audience kind of how it works?
Sure, yeah. So we use a third party, actually a couple of third party folks that give us imagery that's been sort of either AI and or ground, corrected for impervious surface across the whole city. We remove all of the right-of-ways out of the impervious surface layer, and we also remove things like sidewalks, where a registration issue in the imagery and where the right-of-ways would be might cause a public walkway, to be considered, in that case, part of that property. We don't want to do that. We don't want to overcharge everybody. So it's actually a little bit of a painstaking thing to go through individually, make sure that what we're calling impervious surface on each of our 8,000 parcels is accurate. So,
And so how do you assess the fee?
and then the fee is based on what we call an ERU, which is a building unit. That's so for us at 2,280 square feet is the average median or mean, I should say, impervious surface for a single family home in the city of Martinsburg. So each, city or town is going to have a different ERU, and that we have it based on that sort of single family home. The idea being that in the city of Martinsburg, if you own a single family home, a typical single family home, your billing unit would be 1, and for us, that's $12 per ERU. So from there, it scales up, just by how much impervious surface there is. And then there's a minimum charge of a half an ERU.
So it's like instead of charging people for the water that's coming into their home, you're charging them for the water that can't drain or infiltrate on their property?
And that's actually a bit of a misconception there, right? Because we get a lot of phone calls, and we're attributing runoff to impervious surface. So we don't have anything to do. We as humans generally, on a day-to-day, don't have anything to do with the water that's coming down. What we do have control over is the amount of impervious surface on our property. So that impervious surface in scientific models shows the decrease in macroinvertebrates based on the amount of impervious surface. And if you look through those models, you'll find you don't need a lot of impervious surface to degrade surface waters with the pollutants that come in surface runoff. So.
All right. So Lou, do you want to talk about what you would like to improve in stormwater management?
Yes, and Karen, I have to say, listening to Jared and Ellie, I mean, these are incredibly busy professionals. They've got a lot on their plates. And the Chesapeake Bay program comes along and says, oh, here's some future IDF curves that you can implement in your spare time. So
Well, that's why you need consultants like us to help you do that, right?
Right, exactly. And so it is necessary to have these future climate-adjusted IDF curves, but it's insufficient. So consider someone, a stormwater practitioner, a manager, a practitioner, having to deal with an existing or maybe a redeveloping or maybe a new, say, hospital. What do they do with culverts? What do they do with stormwater management? What do they do in terms of the roads and making sure that that facility is available to the community 24 hours, all conditions, all times? So, you look at basically confidence curves and you look at future climate change IDFs, not the hydrology of 2050 to 2000, but the hydrology of presently up to, say, 2075. And you begin. But beginning also means developing model ordinances, developing guidance, providing help to practitioners like the people I'm sharing the stage on so that they can implement these things and understand how to go forward with them. So it might be, for example, devising strategies to minimize risk and developing comprehensive legal codes and ordinances and development regulations to reduce vulnerability. So these things are happening. They're going to be happening nationwide with the Atlas 15. We're fortunate in the Northeast Corridor, at least in the Chesapeake region, to have an early start on this. And we're not the only ones. This is being supplied by a partnership or a collaboration of RAND and Carnegie Mellon University and Cornell University. And this work also will be supported in terms of the American Society of Civil Engineers, the American Water Resources Association. All of these agencies are in this game too, working with NOAA when they bring out the Atlas 15 in order to provide communities everywhere in the US the information and knowledge they need to implement.
All right, so 30 seconds each. Sorry, not a minute, 30 seconds. Final thoughts. Ellie, do you want to start? Or a final thought?
I think from what we heard from Jared and Lou, both of them, they had the great points from the design all the way to the communication, dealing with the public. But truly, I think at the end of the line, the science is there, the engineering, science, knowledge, and to me, it's more collaboration between the local governments, state, federal, communities, property owners, property management companies, and contractors. It takes a village to design all the way from controlling this intense storms that, as previous panel just mentioned it, because of the climate change, we can't control that. So it's coming. We have to maintain, we have to control, make sure that there's no downstream flooding happening. In order to do that, we have to design it properly, we have to inspect it, and we have to maintain it properly.
Jared?
I would just say, we have sort of our individual topics we're listening to here and try to keep ourselves focused, but ultimately it's all connected. I could talk about any part of my job for ad nauseum, and I know that everybody probably in here could do the same, but it's all interconnected. So I think that in terms of moving forward, it's something that we have to think about, that stormwater isn't alone and by itself. It's part of development. It's part of the growth of our communities.
Water's going to go where it wants to go.
We'll do that.
What about you, Lou?
Right. With climate change, we have a multi-generational challenge. We have a challenge that is the engineering challenge that is global. And our piece in the Mid-Atlantic infrastructure region is how to deal with climate change and of all types, but stormwater in particular is the topic today. And it's going to be an E3. That is everything, everywhere, with everybody. If you've got some infrastructure, you're in the game, and you're going to have to get ready. We are all in this together, as Ellie had said, and we'll be moving forward.
So thank you for your attention and your time. And if you want to talk to any of us, we'll be out in the other room. Thanks, Ken.